Hello, my name is Mike Smoyer, President of Digital Government Institute. Thank you for joining us. Our topic today is moving from digital disruption to digital transformation, agency opportunities. Cloud-based data management, business-driven mobile applications, streaming data, legacy systems, and more all combine to challenge government IT professionals to keep up in an age of constant change. Real progress hinges on IT modernization and digital transformation. But by using a secure digital platform, it is possible to engage all agency stakeholders to plan, design, and govern government IT transformation and drive digital strategy from concept to implementation to governance. Before we get started, I just have a few quick items to review. First, we will be emailing an archive version of the webinar to you so you can share it with a colleague or view it again in the future. At any time during this presentation, if you'd like to submit a question, just look for the Q&A window on your screen. We will address questions at the end of the presentation. If you're having any technical difficulties, click on the Help button. And if you're interested in learning more on this topic, please visit digitalgovernment.com. It's now my pleasure to introduce our speaker today. With us is Darryn Graham, Chief Solution Architect, Software AG Government Solutions. Darryn is an experienced system architect providing technical and architectural thought leadership for civilian defense and intelligence agencies. As a Chief Solutions Architect, he designs enterprise software solutions for customers, helping to shape and evolve IT architectures for mission success. Thank you for joining DGI today. We look forward to the next hour. Darryn?
Thank you, Mike. Good afternoon, everyone. So our topics today focus on how agencies can move from digital disruption to digital transformation to enable greater support for agency missions. In order to start with success, organizations need to create disruptions innovatively. So let's take a moment to define what is meant by disruptive innovation. I found a really good explanation over at the Wikipedia website. As you can see here, there are a couple of key aspects to disruptive innovation that I've highlighted. It starts with the creation of a new market opportunity, which at some point disrupts an existing market, and eventually at some level of maturity will displace the firms, products, or services of an established market. To adapt this to government agencies, we can replace the word market for something more appropriate or better suited like technique or solution or even program. But it's not enough to be innovatively disruptive. Organizations need to use disruption as one of the several key aspects to becoming transformational. So let's take a look at a couple of examples of organizations who I think have successfully leveraged disruptive innovation to foster transformation, not only of their own organization, but others as well. A great example to start with is the website I opened with, Wikipedia. So when I was growing up, one of the things that families would invest in would be a shelf full of books that, according to the old advertisement, which you can see on the right, contain the sum of human knowledge, which is a pretty bold statement when you think about it. It implies that human knowledge is finite and static in nature. So what happens when we put a human on Mars? We'll need a new book. And this is probably why the Encyclopedia Britannica stuck around for so long. You know, it's funny, looking back at my youth, I remember asking my parents to explain various topics, maybe to complete my homework or just because I was interested in something. Their reply was always the same. They said, go look it up in the encyclopedia. However, the odd thing is that today, I don't think I've ever had to say that to my kids. And it's not just because we don't have a shelf full of encyclopedias in our living room. I think it's because my kids' generation have new sources of information like Wikipedia that they can discover themselves and that are intuitive for them to navigate and explore. So for Wikipedia, I think it goes beyond simply disrupting a market where encyclopedia salespeople travel door to door and sell an investment in knowledge. You could argue that they've actually transformed the way that people research information and learn. A second example is the popular online transportation company Uber. You can see some of their impressive statistics that this particular organization has grown and created a new market. They've disrupted taxi companies around the world, and yet this global transportation company owns no vehicles. The market for this kind of service grew very quickly, driven by adoption and seemed to practically appear overnight. It wasn't long before Uber found themselves competing with other companies like Lyft, Via, and Haxi, to name a few. My last example today is a company that I think really exemplifies disruption to transformation. You might remember that Netflix originally started as a company that rented DVDs and distributed them through the Postal Service for a monthly fee. It wasn't until 10 years later, in 2007, when Netflix introduced its streaming service to a small number of customers. For most of 6 years, Netflix streamed content to these customers for a monthly fee, yet this organization owned none of the content. This company not only disrupted the traditional VCR and DVD rental businesses like Blockbuster and Hollywood Video, but it also disrupted cable TV providers. It's a little bit different today in that Netflix is also transforming by producing its own content now. You may already be a fan of the show House of Cards. The interesting thing for me about House of Cards is that Netflix created this series without a pilot episode to test viewership. One of the lead actors, Kevin Spacey, spoke once at a convention and said that Netflix was the only company who said, "We've run our data and it tells us that our audience will watch this series." So Netflix is transforming from a media transmission company to a media producing company. And the wow moment for me was how they innovatively used the viewing data from their existing customers' behaviors to help reduce the investment risk when deciding what they were going to produce. Because Netflix allows users the freedom to watch content at their own pace, episodic content does not need to include techniques like cliffhangers to keep viewers tuning in week after week because they can watch back-to-back episodes at will. So similarly to the way that Wikipedia transformed the way that people research information and learn, streaming media companies like Netflix are changing the way that content providers actually produce shows. So let's explore some of the common themes across the backgrounds of these organizations. First of all, they all leverage technology in an innovative way. So in the Wikipedia example, they made their content open and editable by anyone. They relied on the knowledge base of the community of users to police and edit the content and provided an audit log of all of the changes so that they were transparent. Obviously, this is a drastically different protocol from the encyclopedia model. Mobile computing is another important aspect to these organizations. In the case of Uber, they brought together drivers and riders who are both inherently mobile. So the innovation of directly tapping into this moving network of supply and demand is what makes Uber so interesting and valuable. Netflix made a very innovative decision to expose their service as an application programming interface first, an API, and then build their viewing components on top of that. What that allowed Netflix to do is open the door for various hardware platforms and companies to consume their streaming content through these well-defined APIs. This means that you don't need the phone app that Netflix built in order to view their content. Netflix also runs on a dizzying array of smart TVs, video game systems, and DVD Blu-ray players. So APIs are a very important aspect of this. The other thing I noticed about these storylines is that innovation seems to happen very quickly, sometimes overnight. However, the adoption or the application of that innovation within an organization or market, or more importantly, a market, that's what drives transformation. And that seems to happen at a relatively slower pace. So as I think about the examples of organizations that use disruption and innovation to foster transformation, I can identify some challenge areas with traditional approaches to digitization and modernization. I continue to be surprised at how many organizations are hampered because they're separated along organizational boundaries. While there may be a tighter collaboration at the highest levels of leadership within the agency's mission and their supporting IT organizations, this cohesive orchestration often seems to be missing in the wider majority of the organization. Sometimes I get to interact with both sides of this coin, and I get to see both perspectives. And there is no right answer. I can relate to the frustrations and disconnection felt from both sides. Additionally, the primary applications and systems of record within an organization are often limited in terms of their ability to rapidly change. And that's not to say that they lack the ability to be customized. Rather, they lack the ability to disrupt because often the amount of time it takes to plan, implement, test, and deploy changes in these systems is too great. And finally, especially in the federal space, the IT landscape is often very brittle and complicated. One reason for this is because we're dealing with massive enterprises. Because of the competitive nature of procurements and contracting, agencies may have periodic revolving doors as contractors and systems integrators move on and off of implementation projects. The result creates massive heterogeneous environments where the skill sets of the implementation teams really drive the technology and the footprint over decades. So I've been fortunate enough to be able to work with some of our largest customers, both in the private sector as well as in the U.S. federal space for the past 13 plus years. And as these organizations looked at new technologies to potentially incorporate and address transformational change, I got to see some really good insight on common problems and patterns. So I'll take a few minutes to paint a picture of what I'll call a current state, which I found to be fairly prevalent across a wide variety of companies and agencies. And we'll use this to talk about how agencies that have been successful in handling disruptive technologies can be used as an example so that other agencies can set themselves up for innovation, effective modernization, and ultimately transformational change. So what you see in the left is probably something similar to what you've seen in your travels. In my experience, this is common across many organizations, both in the private sector and government. We see lots of applications that have been connected together in a point-to-point fashion. There are typically one or more large financial or ERP systems, perhaps one or more data warehouses, maybe some file transfers to partners or vendors or other agencies, and probably many end-tier web architectures. We're also continuing to see adoption of cloud technologies beyond using cloud for infrastructure and compute resources. It sometimes includes offloading some services out of existing on-premise systems of record to software as a service offerings like Salesforce.com or specialized case management tools or human resource applications that all run in the cloud as a service. Mobile is definitely something we're seeing continuing requirements for. Some agencies want or need to expose some of their internal web interfaces to the internet for mobile access. And these interfaces not only require special connectivity and security constraints, but also require special architecture components to help protect the inner trusted environment. In some agencies, especially in the DoD and in the intelligence community, sensors become an integral part of the architecture as well. This requires specialized connections and repeating the same investments in security and access protection. Because in these situations, the size and speed of data is growing exponentially, some organizations have had some success expanding into big data technologies, but often this type of tooling is limited to historical analysis, and there are cases where real-time analysis of this data is required. When you look at this design pattern, you can see a lot of effort in complexity as well as redundancy. Each time a new framework or new code base are being developed to address particular mission requirements, it's creating duplicate blocks of integration logic, data logs, decision logic, and tasking. And as standards evolve, we layer in even more complexity, for example, developing SOAP services, and then at some point moving to more of a REST-based API. And the integration touch points grow by large factors because the number of repetitive places that are impacted with any new change. So what we find with this situation is that it likely leads to costs going up, complexity and the inability to increase change going up, and the opportunities for innovation and transformation going down. Now, there are some alternatives that some of our customers have put in place and achieved success, so let's take a look at those. On the right, you'll see an alternative state, a digital business platform. Our customers typically start their journey toward a modernized digital business platform by implementing an enterprise service bus. The bus initially was used to solve point-to-point integration problems by loosely coupling applications and using things like a publish and subscribe paradigm, enabling integrations to become easier to manage and change. However, the bus has evolved from this original purpose to synchronize data by service-enabling back-end applications. Because the bus has unique access to the data within and between the applications, it can also be used to help discover interesting insights and surface them as events. In these events, they can include traditional application data events, but also from sensor data, from Internet of Things, weather, logistics, supply chain, social media, news feeds, you name it. Another interesting innovation I've seen is to combine the bus with streaming analytics of in-flight data. This enables events to be correlated in real time to identify opportunities that agencies can leverage to engage citizens, respond to emergencies, alert management, or simply take other actions. The key here is to detect situations early enough to be able to take action and influence the outcome. Solutions built on top of the digital business platform leverage a commonly defined set of capabilities around security, integration, performance, and scale. These solutions can be implemented as a service-oriented architecture or a microservices architecture deployed within virtual containers that can be elastically scaled to match the ebb and flow of transactional volumes. End users on mobile devices and web browsers can access these capabilities in these solutions via an API layer that provides the security access control to only allow the right consumers access to the right and appropriate information. This same API layer can also implement cyber defense tactics required to help protect the internal trusted system of record from outside attacks. Solutions can be built for change and quickly assembled from reusable components. And as requirements change, you can evolve your applications, building new ones rapidly to address the emerging requirements, while still leveraging the underlying reusable business logic hosted by the platform. And as organizations continue to adopt cloud solutions, they further blur the line between on-premise and off. In other words, if you're, quote, leveraging the cloud, you're really in a hybrid scenario where supporting on-premise and cloud at the same time presents unique challenges. In these types of deployment scenarios, it's even more important to have a bus which can facilitate data movement securely, not only internally, but externally as well. So here's another way of looking at what we've been talking about. This is a high-level 2B landscape architecture that creates a layer of abstraction which fosters an ability to evolve. Along the bottom are the existing systems of record, and along the top are some of the newer technologies and services like cloud-based software as a service, big data solutions, and mobile. What agencies need is the ability to coalesce these different models and create systems of differentiation. This combination sets the stage for digital transformation. So in order to achieve transformation, we can categorize capabilities into 5 major building blocks. For many of our customers, it all starts with integration. This is the technology that enables us to unlock these various systems of record to enable bidirectional data exchange and the exposure of the business logic that these systems are comprised of. What makes integration technology truly powerful is its ability to interact with systems which originally were not designed to be integrated with. Unlocking the business logic and the data of existing systems is really a liberating feat when it comes to the task of transformation. It removes so many roadblocks that stymie creative architects who are tasked to build innovative solutions addressing dynamic requirements of an agency. Once the restrictions of closed legacy systems are unlocked, the ability to orchestrate the various pieces of each of them becomes quite powerful. Our customers realize great value from leveraging process automation software, which can take advantage of both the legacy applications as well as the new, more modernized applications. One of the key aspects to ensure success in this area is the technology's ability to bring IT services and people together. Automation solutions should bridge that gap and ensure that both systems and humans are part of the orchestration. Regardless of the level of system automation, in my experience, there's always a human involved somewhere in the flow of data, if only to handle exceptions. Typically, when we're talking about systems that support federal agencies, we're talking about size and scale. One of the techniques I've seen bring some value to organizations is bringing data into memory. In-memory data access speeds far eclipse those data storage systems that are backed by disk. And the proliferation of 64-bit operating systems that can easily address terabytes of RAM have combined with the relatively low cost of random access memory to produce a perfect storm of capability. Further, in-memory data storage nodes can be mirrored together to create a highly available and reliable data store. Groups of these data storage nodes can be clustered together to scale up for larger data sets and to serve data across multiple data consumers throughout the enterprise. This is especially advantageous in situations where customers are providing data outside of their trusted environment. Putting it in memory, putting an in-memory data store in front of a system of record provides a protective shield against usage spikes or request flooding attacks. These three building blocks contribute together to facilitate capabilities to analyze data and facilitate decisions. Analytics can span from a simple dashboard to streaming real-time data to massive big data lakes where historical data can be analyzed. Insights gathered from longer-running historical analysis can be migrated into real-time analytics to provide additional value. So here's an example. Imagine an organization is analyzing real-time cyber traffic between network systems in their organization. Let's say they just measured a large amount of net flow traffic that's flowing between two servers. How can they tell if at that moment that the size of the traffic is anomalous? How can they determine if this is something that requires additional measurement or action? This is where longer-running analytics like MapReduce jobs can contribute insights to real-time monitoring. So there's great value in having both real-time analytics as well as batch-oriented historical analytics working together to provide the data needed for both automated and human decisions. The last building block is one that is often overlooked in organizations that are embracing disruptive innovations in order to transform, and that's governance. To evolve large, complex, and interconnected systems, organizations need to have a clear picture of the current state and the to-be state. They need to understand what applications are based on what technology, which versions of these technologies are deployed, what is their timeline for support, what is their upgrade plan, if any. The governance layer should also ingest cyber threat data and facilitate assessment against the portfolio of deployed components within an organization. This helps reduce risk and compliance as the organization transforms over time. So let's take a look at each of these building blocks in a little bit more detail and explore some of the distinct capabilities within each. And we'll start with integration. One of the earliest integration challenges was around moving data between applications internally in an organization. So application integration capabilities should include libraries of application adapters that would allow developers the ability to quickly and easily connect to the application logic and data. Many organizations find themselves with requirements to exchange data outside of their organization. So B2B or business-to-business integration capabilities should not only provide a secure means to accomplish data sharing between organizations, but also provide auditing and visibility for both senders and receivers of data. The integration layer should also provide out-of-the-box services to build integration logic. It should provide data transformation and mapping capabilities, encryption services, routing services, and management and monitoring capabilities. For organizations that are leveraging software as a service, special attention needs to be paid to governing integration and interactions through APIs. The integration layer should provide API consumption and governance capabilities and metrics to ensure that transaction volumes do not exceed the thresholds, which would result in additional cost. Internet of Things and sensors require specific integration capabilities to facilitate data ingest, transformation, routing, and analytics. Mobile integration inherently involves the exposure of APIs outside of the organization. So again, there are special security features that are needed, as well as support for data protocols that are typically lighter weight and can help address situations where a mobile device may be bandwidth constrained. As organizations assemble these various services into orchestrations, the integration layer will need to provide governance to ensure reuse and provide features to help with the impact analysis of changes. Agencies who need to expose APIs outside of their organization will be challenged to provide an interface for external developers to research and understand which API services are available and how to use them. And just like with mobile integration, there are security implications to exposing APIs. So the integration layer must include gateway components that facilitate the incoming requests for data through the DMZ and into the trusted environment. Finally, organizations will require a messaging component which provides the publish and subscribe services across a variety of clients, including sensors, servers, mobile devices, and browsers. One of the key capabilities within the process area is the ability to automate processes. It includes the process authoring as well as an engine that can enforce these processes and shepherd transactions from start to finish. As organizations transform to include process automation, new applications will need to be developed that will run in conjunction with these processes. Also, there will be times when processing a transaction will be more dynamic, where straight-through processing can't be achieved. So the process layer should also include capabilities to support case management-oriented processes where states can change dynamically and unpredictably. Like we saw in the Uber example, organizations are seeing more requirements to incorporate process workers via a mobile device. In process-oriented projects, human tasks are a key aspect. Incorporating humans into a process introduces a number of ancillary capabilities, including managing inboxes, delegations, and escalations. In order to better bridge the gap between mission owners and the supporting IT, the process layer should include capabilities for mission owners to articulate process rules in a non-technical way while still maintaining the ability to create an IT asset which can enforce those rules without developer involvement. In some cases, organizations may choose to expose editing of these rules with hot deployment options at runtime. This allows dynamic updates to be made in the process in a controlled way at specific points in the process. This provides a lot of agility to the mission and helps facilitate transformation. Like I mentioned before, leveraging ultra-fast server RAM provides a lot of opportunities for innovation to support transformation. The InMemory layer should address the ability to bring search or compute analytics together with data in memory in order to achieve and provide the fastest access. And this brings ultimate speed to analytics. In some cases, there may be benefits to offloading data from existing systems of record to in-memory storage in order to save costs. For example, agencies who still rely on mainframes may pay more the more that those mainframes are used. So in cases where this mainframe data needs to be shared more and more throughout the enterprise and even outside of the enterprise, it makes financial sense to deploy arrays of in-memory data stores running on commodity hardware. The integration layer can help detect changes in the mainframe data and ensure that the in-memory data array is synchronized. Another challenge that the in-memory layer can help address is to provide protection when exposing service APIs externally. This is especially useful because there could be potentially a large amount of concurrent data access, which without a protective memory layer could result in increased execution time for existing systems of record as they deal with usage spikes. In the analytics layer, there are a wealth of capabilities that help with decision making. Additionally, depending on the organization, there is likely a vast array of detailed analytics requirements, so the platform should be pluggable and adaptable. At a high level, though, the analytics and decisions layer should include capabilities to provide operational dashboards to mission owners. These dashboards typically contain data derived from the process and integration layers, often combined with historical data. As an organization begins to transform, there may be challenges around identifying existing processing logic in legacy systems. Organizations will need process logic analytic tools to help document their as-is environment and potentially leverage the process of the integration layer to instrument and augment current systems in the early phases of transformation. There should also be analytic capabilities to monitor the processes that are executing within the process layer. At a minimum, organizations should measure intrinsic key process performance indicators like success and failure metrics, process cycle time, and step execution time. The platform should provide the ability to apply statistical algorithms to learn over time what is normal or abnormal, and give mission owners the ability to dynamically configure alerting or spawn reactionary processes to help alter the outcome in a positive way. These algorithms can also be used to calculate likely completion time for in-process instances as well. So a mission owner can have some better insight into how long a particular transaction will likely take to complete. Leveraging this type of machine learning can help identify leading indicators that can be used and algorithms that can provide predictive capabilities. Other algorithms will look for specific patterns across a variety of data sources, including structured and non-structured data. And finally, algorithms may look at event-based data to detect relationships. Sometimes even the lack of an event is an indicator. In my experience, data analytics is probably one of the fastest growing areas within organizations who are looking to be transformative. And last but certainly not least are the capabilities that help support governance as organizations transform. This is where you'll find the details of the as-is and the to-be, along with the strategy of how an organization will execute against a plan to transform. Often, the participants in this part of the platform are organizationally and potentially geographically dispersed. So the platform should provide a collaborative capability to address this division. There should be capabilities to allow agencies to analyze the as-is to help facilitate the creation of the transformational plan. Because agencies are typically heavily regulated, risk and compliance management is a very important part to ensure that risk, transparency, and governance is applied. This is especially true in civilian agencies where capabilities to support auditing and review are essential. One of my colleagues recently described this area of the platform as the ERP of IT. It's the system of record of systems of record. Not only does it keep track of all the detailed IT portfolio and architecture of the enterprise, but it links it all together and along with all of the other aspects, including budgeting, projects, roadmaps, to provide a fully encompassed view of the enterprise. So here's a tangible example of how an organization might apply a digital business platform in order to innovate. The challenge is, how does an organization better connect with customers and create new revenue opportunities? While this is an example from the private sector, we may be able to map similar challenges in ways that agencies would want to better connect with citizens, for example. This use case is the basis for a marketing technique called location-based marketing. Location-based marketing is a marketing method that changes depending on where customers or often potential customers are located. So instead of treating customers as a monolithic entity, location-based marketing adapts to the particular social, cultural, or personal traits of their customers by making assumptions about their habits and preferences based on their location at a particular moment. Technological advances have allowed companies to know much more about their clients' locations so they can target these clients individually. So the first step is to use the business and IT transformation capabilities to map the customer's journey. A customer journey map tells the story of a customer's experience with an organization, from initial contact through the process of engagement and into what is hopefully a long-term relationship. The map identifies key interactions that the customer has with the organization. It captures the user's feelings, motivations, and questions for each of these touch points. Next, the organization maps these interactions against the existing IT portfolio and identifies systems and technologies that support them. This mapping can be used to reveal gaps and highlight specific areas for improvement. In this example, the organization provides their customers with a loyalty app that's installable across a wide variety of mobile devices, but specifically targets cell phones. This provides an opportunity to use the data gleaned from the mobile device and leverage it in some interesting and innovative ways. So in this example, we're leveraging a loyalty app, but any other functional app that the customer chose to install from the organization could provide some of this. You can see that the integration layer is key here, and it's used to help connect customer and product data with the end customer. This is a great example of fusing sensor-type data coming from a mobile device with existing systems of record within an organization. It also highlights some of the technical challenges specifically around edge security and bringing data from non-trusted environments into the organization. This is exactly where API services components provide a lot of value in facilitating this kind of data movement in a secure way, not only protecting the data as it moves between the mobile device and the organization, but also insulating the internal systems of record from usage spikes or attacks. In order to help scale and meet the demands of a highly concurrent real-time system, the organization leverages an in-memory data store. One key benefit of this is to provide that protective layer that insulates them from usage spikes and from protecting the existing systems of record. But there are many other benefits, including reducing operating costs by offloading some of that customer data from the mainframe. So here's where things can get interesting. part of the data that's being collected from the loyalty app is the customer's physical location. So the organization knows where the customer is and is monitoring their latitude and longitude. So this data is being streamed in real time to a component in the analytics and decisions area. Concurrently, the organization is also monitoring weather data provided via an API from a weather service provider. So using the customer's GPS location and fusing that with the weather data, the organization can detect that a storm is headed toward the customer's location. These disparate streams of data, in this case customer location and weather, are being constantly evaluated by algorithms that are running in the streaming analytics component. The analytics component is capable of injecting these algorithms for pattern detection and data analysis dynamically at runtime, and this brings a lot of agility to the organization so they can make decisions effectively and quickly. Now that the algorithms have detected that the customer may want to get out of the storm, a pre-built reaction process is spawned to help the organization evaluate potential actions. By integrating the data from finance and marketing systems, the process has determined that a restaurant that the organization partners with is nearby, and they're currently running a special. So the organization can use this information and send an alert to the customer through the mobile application that a storm is coming and that they're right next to a partner restaurant who's offering $5 off of their lunch meal. And finally, the sales organization can use dashboards and other visibility into these types of transactions to get better insight into the behaviors of their customers. For example, they may use historical analytics to determine the types of restaurants that a particular customer prefers. I think this example does a really good job of illustrating how each of the capability areas of the digital business platform can be used together to solve the challenges of an organization and provide the kind of disruptive innovation that helps with transformation. Let's take a look at one more example which focuses on how we can use the digital business platform in a cybersecurity flavored use case. First, the business and IT transformation area of the digital business platform periodically ingests data from the National Vulnerability Database, or NVD. The NVD is a U.S. government repository of standards-based vulnerability management data, and it's represented using the Security Content Automation Protocol. This data enables automation of vulnerability management, security measurement, and compliance. The NVD includes databases of security checklists, security-related software flaws, misconfigurations, and it includes product names and impact metrics. The NVD is a product of the NIST Computer Security Division and is sponsored by the Department of Homeland Security's National Cybersecurity Division. It supports the U.S. government multi-agency information security automation program. Because the data that's provided by NIST is in a structured machine-readable format, the business and IT transformation tools can automatically import this data. The tools provide capabilities to assess the relevance of imported vulnerabilities against the existing technology landscape, which is documented in the IT portfolio. It uses the common vulnerability scoring system to help IT leaders perform risk assessment and determine if any mitigation steps are required. For vulnerabilities requiring mitigation, the tool provides documentation of the demand or compliance control that would be implemented to implement the mitigation. Ideally, the tool provides a dashboard to provide visibility to IT leadership to include a Gantt chart, for example, showing the life cycle phases of associated components, including those of subordinate groups, or a bar chart showing threat distribution over time and categorized according to the common vulnerability scoring system. Next, the organization uses the integration layer to connect to the automated indicator sharing service, which is provided by the Department of Homeland Security's National Cybersecurity and Communications Integration Center, or NCIC. The AIS uses two standards to share cyber threat indicators called TAXII and STIX. TAXII defines a set of services and message exchanges that enable the sharing of actionable cyber threat information across organizational, product line, and service boundaries. STIX is a standardized, structured language to represent the cyber threat information. The STIX standard conveys the full range of potential cyber threat data and it is expressive, flexible, and extensible, and most importantly, automatable. Next, the organization receives a message containing information about an observation that an IP address has been targeting a vulnerability in a specific version of firmware in a router. A process is spawned to investigate whether the organization has deployed any of these routers, and if so, which version of the firmware they're running. So the process inspects the portfolio data that's maintained by the business and IT transformation tooling. Data in that system of record also provides visibility into mission impacts, budgets and spending, and project life cycles. Based on some rules that have been articulated by the IT leadership and implemented in the rules engine, the process may orchestrate a human workflow to facilitate upgrading or patching of the firmware. One of the advantages to using the rules engine to make decisions in this way is that it provides some flexibility to the leadership to make some changes at runtime. So if the organization has, for example, different levels of defense posture, the rules processing the sticks data may behave differently and enforce a more active defense. In parallel, the organization is monitoring their network data in real time. Because they exchange data with some external partners, they're used to dealing with traffic that originates outside of their network. But occasionally, they see IP addresses that are unknown or worse, have been provided by the AIS system as potential adversaries. Detecting this traffic may kick off a process in order to do further investigation or evaluation. A more sophisticated process may provision a honeypot network in the cloud using APIs and proactively route the intruder into there for further containment or analysis. Typically, sensor data is like crude oil. You need to refine it in order for it to be useful. In the example of network sensors, the number and breadth of data elements is really limited. So the real-time analytics that are running against that NetFlow data may also need to leverage third-party reputation service providers to see if the IP addresses have been used in the past for attacks or to get other data about that address. Because IP traffic is very high volume, the organization can leverage the InMemory component to limit the amount of calls made to the service provider when they're working with the same IP address. This helps the organization scale and protect back-end data sources which are used to augment real-time data analysis. Next, let's take a couple of actual Software AG customer case studies that have transformed using disruptive innovation. The Internal Revenue Service is one of my favorite customer examples because really just about anybody can relate to it. This is because everyone has to file a tax return. While we support a number of programs within the IRS, the modernized e-file program is one of the best examples of how applying an integration layer helps organizations transform. Depending on your age, you may remember that once upon a time, tax returns were prepared on paper and mailed to the IRS for processing. The decision was made for the IRS to transition to electronic filing. However, the adoption of electronic filing was initially slow. However, as the complexity and volume of filings continued to grow, the IRS identified the need for a system that could securely and robustly ingest all of the filings and provide guaranteed delivery to the appropriate IRS systems for processing. One of the main challenges is that there are a number of disparate systems that are used to process tax returns today. So the agency required a component that could act as a backbone for multiple systems and programs. So I can explain a little bit about how it works without revealing any sensitive details about how the IRS actually processes your tax return, as they typically frown on that. Anyway, a large portion of your tax returns are filed together through a tax preparation service. These services gather many, many tax returns and submit them periodically in a batch fashion to the IRS for processing. Even if you complete your forms using your own computer, typically the tax software provider that you use will bundle up your return with many others and submit it periodically to the IRS. So the integration layer at the IRS will receive these data submissions securely, parse and validate the formats, and break them up into individual transactions that get routed to the appropriate systems for further processing. So from a technical perspective, this is very challenging as the files that they receive can be quite large, especially if you consider simply parsing the files, let alone any other validation or other data checks. So the IRS uses innovative capabilities of our integration platform to be able to process this data at scale. Using these disruptive technologies in a novel way allowed the agency to transform from a primarily paper-oriented organization to the fully automated electronic one, saving significant time and money along the way. Another great example of transformation is the Centers for Medicare and Medicaid Services website, healthcare.gov, and the related back-end services. So here was the challenge. With the passing of the Affordable Care Act, a central exchange needed to be built to allow enrollment for health insurance policies offered through a government exchange. Multiple policy options at different rates and coverages and covering different geographies would need to be maintained, along with obtaining financial information to determine whether individuals are eligible for potential tax credits. Due to the typical open enrollment periods, this process is performed during a relatively small window at the end of the year and covers millions of potential individual users exploring their options. So as you may have seen in the news, the initial launch of the service was unable to scale to the volume of concurrent users. Without a quick and effective solution, the ability to provide the program during the first year was in jeopardy. One of the corrective choices that the CMS leadership made was the deployment of an in-memory data store, and the results were really fast. An immediate impact was made with the introduction of this in-memory data store. Website response times immediately were made faster, and with in-memory session management, additional concurrent users were able to be supported. Data from over 200 back-end systems were brought into memory for lightning-fast access, and the project leveraged the mirroring capabilities to improve resiliency and performance of the in-memory data. The program was eventually successful, and open enrollments were able to complete the first year. Since then, the same systems and processes were utilized to support open enrollment, which completed without incident. The new system, utilizing the in-memory data store, easily supported all approximate 160,000 concurrent users at its peak. I like this next customer story because it not only illustrates how an organization can transform to exponentially affect performance, but it also provides a positive impact on the environment. This is one of the world's leading maritime information and service providers. It has been in business for more than 100 years, so as you can imagine, it has had to rely heavily on innovation and transformation to remain competitive. This organization supplies information and communication technology services to virtually all segments of the maritime logistics market. They handle more than 200,000 ship movements per year, and more than 800 organizations rely on them for up-to-date maritime information. Their most recent challenge was to undertake a major initiative to enhance the quality and accuracy of data used to support maritime operators. All ships and vessels are equipped with something called the Automatic Identification System, or AIS. It's used to provide unique identification, to provide position, course, and speed of maritime vessels. The company wanted to incorporate these AIS messages in their process of monitoring vessel voyages, thus creating the ability to provide advanced triggers that could alert operators about events needing their attention during the vessel's voyage. This required that they transform by leveraging a new analytics technology at the time called Complex Event Processing, or CEP. And they use CEP to analyze this vast amounts of AIS data in real time. Using a CEP engine, the company can quickly generate statistical information about vessel movements. The company continuously receives ship data such as position, speed, and heading from its transponder network, partner network, and also satellites. It then combines this with other data such as berth availability, availability of nautical services, position of other ships, weather conditions, and then they analyze that all in real time. Results are distributed to port authorities, shipping agents, and logistics service providers. So by creating this disruption, the company has been able to launch new revenue-creating services and expand into new markets. Internal processes are now streamlined, and the internal costs are reducing. Operators can concentrate on using their knowledge to advise their customers rather than searching for relevant data. Customers use their insights to better plan and synchronize their activities to lower costs, optimize resources, reduce carbon emissions, and ultimately use less fuel. Prior to their transformation, monitoring was done using traditional relational databases and automation scripts. Making changes and adding new alerts was very complex, and it was time-consuming as well. Their initial deployment of the CEP engine handled about 1,500 messages per second in real time, which was about a 300% increase in capability. So we're coming toward the end of the time allotted for our session, so let's review what we've talked about. We've talked about disruptive innovation and how the application of it helps organizations become transformational. We saw organizations that transformed markets. We saw organizations transform themselves. We look at some of these similarities that the organizations share and some of the things that set them apart. I hope you'll agree that there are a number of key underlying themes that we can use to set up governmental agencies with the right parameters under which they can move from disruption to transformation. Next, we talked about some common architectural challenges. We reviewed about how this changed over time and how this leads to a very costly, complex problem which really stifles innovation and the ability to change. And then I introduced you to some of the concepts of the digital business platform. We talked about the advantage of creating an abstraction layer and the freedom that it brings to innovate. Next, we dove right into the details about the 5 building blocks of the digital business platform: integration, process, InMemory, analytics, and governance. We learned that this is only the tip of a very large collection of icebergs, and that a comprehensive platform requires a significant amount of capability. Next, we showed a couple of interesting examples of digital business platform in use. The first one showed how the platform can monitor the GPS location of important assets. In our case, we used customers, but these could also be citizens or even adversaries. Combining location with weather information and a marketing database, we saw how an organization can transform and open new revenue opportunities. The second example focused on cybersecurity. We saw how the digital business platform can connect to a variety of very helpful and extremely valuable cyber data resources, most of which were provided by the government. We discussed how we can improve our cyber defense posture by leveraging existing cyber threat data that is shared across the government and, additionally, the private sector. And we saw how the data from a real-time network monitoring could be enhanced and leveraged as part of the larger picture. And then after that, I shared a few specific customer stories which may or may not have reminded you that tax season is fast approaching. So I'll go ahead and turn this over to Mike to help facilitate any questions that you might have.
Thanks, Darryn, and thanks for the update on tax season fast approaching.
Sorry to remind you.
April 2017 down the corner already. Before we dive into the Q&A, Darryn, I just wanted to remind everyone out there there's still time to submit a question if you have one. And also, DGI will be emailing an archived version of the webinar within the next day or so. So with that said, here's the first question. Are the capabilities you described in the platform all supposed to be individual products?
No, not necessarily. So there may be cases in which multiple capabilities are served from the same underlying technology component. For example, with the Software AG integration platform, the capabilities like application integration, B2B integration, cloud integration, these are all deployed within a single common runtime. And what this does is it provides our customers flexibility to run them either all together or they can break them up, into a more of a microservices architecture approach. So the answer probably is it depends, and this is of course going to differ depending on from vendor to vendor, depending on the implementation. But I do think that in all cases, wherever that functional split is from components, it should be designed with loose coupling at the forefront. So it should be a service API enabled so you can sort of mix and match these components as needed.
Okay, and I think this next question is referring to the cybersecurity example you shared. How does the platform handle patching and or fixing to resolve various cyber vulnerabilities? Tongue twister there.
So that's going to depend on the vulnerability and on the asset that needs to be patched. I don't think there's really a cookie-cutter approach to it. So, for example, if there's a vulnerability in, let's say, some particular version of the Java virtual machine, there might be some significant testing and validation that you need to perform in order to make changes and make sure that the changes that are applied to address the vulnerability will not break anything before you move it into production. So while you could use like a process orchestration kinds of capabilities to manage that, there's probably already an SDLC or software development lifecycle process that's already in place that manages these kinds of efforts. But if you were going to handle a different kind of asset, let's say you need to reconfigure a firewall, let's say, to block an IP address, using the example that we were talking about. Let's say that an IP address has been observed and it's known to be malicious, and you as an IT leader need to make sure that you're blocking that IP address. That's something I think that can happen a little bit more fluidly without a lot of testing, because you're just blocking a particular IP address. So the flip side of that is if you were leveraging any of like cloud infrastructure providers and you need to make those changes in a cloud infrastructure, they've already got services that you can call that perform those kinds of configuration duties. So you don't actually need a human in the loop to do that. You don't necessarily need a lot of testing and validation that has to happen. So you can actually fully automate something like that. So yeah, I guess it just kind of depends on what you need to do to react to the situation. Either way, I think there's a lot of value in using some form of process automation and orchestration to facilitate that kind of decision-making and tasking.
Okay, since we're coming up on the top of the hour here, I'll make this the last question. And for those of you that submitted a question we can't get to, we'll make sure to follow up with you afterwards. So the last question here is, how important is internal communication, education, and training when undergoing major reforms like digital transformation?
Yeah, that is definitely an important aspect, and I need to stress that that's extremely important. Really, any kind of major reform or any kind of change is going to require change management. The bigger the transformation, the more important and the more specific your change management efforts need to be in order to help everybody understand the value of the change. And this is especially true in agencies where you have long-term employees. So, as flawed as their system might be perceived today, employees are comfortable with those flaws, and they're uncomfortable with this unknown new system that's going to be coming, right? So for things that you can create demos for, those are really helpful to show like ahead of time. So here's what your system is going to look like. Here is how we're going to fix that pain point that you have to deal with every day. I think it's really all about transparency and bringing that together with change management in order to allay those fears and also to get buy-in from folks who may be skeptical.
Well, Darryn, thank you and Software AG for your support of the webinar today. I think that we're going to hear a lot more on digital transformation and IT modernization as we head into 2017. So thank you for addressing the topic today. I'd also like to thank our audience for tuning in. We very much appreciate your continued support. On behalf of Digital Government Institute team, this concludes today's webinar. Have a great day, everybody.